In this video, we're going to talk about supplemental examples from section 7.1. We're going to start with a supplemental example that we did as an example in the notes here for this section. So let's go ahead and get started. This was example 2 in the notes. Curves that intersect at more than 2 points. So find the area of the region between the graphs of f of x is equal to 3x cubed minus x squared minus 10x, and g of x is equal to negative x squared plus 2x. I'm going to go ahead and pull up a graphing calculator here on the side to help us with this. So give me just a second for that. All right, most of you are probably familiar with the Desmos graphing calculator since we use it for SOLs here in Virginia. So I don't think I need to tell you a whole lot about how to use this, but this is an open educational resource that's available to you for free online. Just go to desmos.com and select the graphing calculator option. So we want to find the points of intersection. I'll do that algebraically, but I'm also going to show you how to do that with a graphing calculator here. And then we have negative x squared plus x, like that. And I'm interested in this point of intersection over here, this point of intersection there, and that point of intersection there. So I'm going to have, let's go ahead and find those points there algebraically. 3x cubed minus x squared minus 10x needs to be set equal to negative x squared plus 2x. And when I add x squared to both sides, those terms go away. Keep the 3x cubed positive, so this is going to be 3x cubed minus 12x is equal to 0. Pull a 3x out as a common factor, and I get x squared minus 4. For the other piece, that's 3x times x plus 2 times x minus 2 is equal to 0. So 3x is equal to 0, or x plus 2 equals 0, or x minus 2 equals 0. So x equals 0, or x equals negative 2, or x equals 2. At x equals 0, I'm going to have 0, 0. At x equals negative 2, going to stick that into this piece is going to be a negative 4 minus 8. Negative 4 minus 2 times, that's going to be a negative 8. Yep. And then we have at 2, this is negative 4 plus 4 is 0. All right. So integration time, we're going to have 3 pieces that we're interested in. We're interested in the boundary negative 2 to 0, and then from 0 to 2, like that. Those are the only bounded regions here, and there. So only 2 intervals. And let's give myself some more space here. So in this region here, I'm going to have upper function is the cubic and lower function is the quadratic. So I want to have 3x cubed minus x squared minus 10x minus then my quadratic was negative x squared plus 2x. There's a dx to close the integral there. Now I have my upper function as my quadratic and my lower function is my cubic. I have a negative x squared plus 2x minus 3x cubed minus x squared minus 10x close that up with a dx. And so this is going to be -2 to 0 of 3x cubed. Negative x squared minus a negative x squared is negative x squared plus x squared is 0 x squareds. Negative 10x minus 2x is a negative 12x dx plus 0 to 2 of, so let's start off with the x cubed part. That's a negative 3x cubed. And then a negative x squared minus a negative x squared is 0x squareds. 2 plus 10 is 12x dx, like that. While I could factor out, I'm not going to. I'm just going to make this 3/4 x to the 4th minus 6x squared, evaluated from -2 to 0, plus, and then negative 3/4 x to the 4th, plus 6x squared, evaluated from 0 to 2. That's even, so, and this is symmetric here. You can kind of see that better with the graph there. So let's go ahead and just double this piece right here. Actually, that's not necessarily the same, because those signs are opposite. So let's go ahead here and say this is 0 minus 0 minus, and then that's 3/4 times 16 minus 6 times 4, like that. It probably will be the same thing, plus a negative 3/4 times 16 plus 6 times 4, then change my signs. It's going to be plus 3/4 times 0 minus 6 times 0. So those terms are 0, those terms are 0. I have a negative 3 times 4 is 12 minus 24, and then a negative 3 times 4 is a negative 12 plus 24. So that's going to be a negative 12 plus 12 is 12 plus 12 is 24. There we go. Let's find the total area between the functions of f of x is equal to sine x and g of x is equal to cosine x. So sine x, oops, f of x equals sine x and g of x is equal to cosine x. We want to find those points of intersection between 0 and 2 pi. So x-axis is going to go between 0 and 2 pi. Steps of pi over 12 for me would be great. And I want to go from -1 to 1 on y. And I'm interested in points of intersection here, which are there and there. So we have, because this is completely bounded, it's cut off at 0 here. I'm going to go from 0 to pi over 4 with cosine minus sine plus pi over 4 to 5 pi over 4. Then that's sine minus cosine plus, and then there's 5 pi over 4 to 2 pi with cosine minus sine like that. So this is going to be sine minus, so plus cosine, minus a negative cosine is plus cosine, and that's from 0 to pi over 4, plus, and then these are going to be the opposites of that, so this is a negative cosine minus sine from pi over 4 to 5 pi over 4, plus, and then this is sine plus cosine again from 5 pi over 4 to 2 pi. This is root 2 over 2 plus root 2 over 2 minus 0 plus 1 plus at 5 pi over 4, that's a negative root 2 over 2, negative root 2 over 2. So this is negative, negative is like that. And then plus root 2 over 2 plus root 2 over 2 plus sine of 2 pi is 0. Cosine of 2 pi is 1 minus, then this is negative for everything on the inside, so minus that negative is going to be root 2 over 2 plus root 2 over 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 times root 2 over 2 is 4 root 2. This is square units, as is this one up here, since we're talking about area. This one's going to tell me to sketch the graphs being integrated and shade the region of integration of the following integral, but it doesn't want me to solve it here. Show you, I'll let Desmos do the integration for you and give you the answer. So graphs here are going to be upper function 2 minus y. Start off with the y-intercept of 2, down 1, right 1, and then down 1, right 1 at this line. And then we have y squared, 0 to 1, 1, like that, 2, 4, and then negative 1, 1, and then negative 2, 4, yeah. They would also intersect up here. And I'm interested in this region here, right there. This is y equals 2 minus x, and this is y equals, oh, actually I need it to go the other way. These are dy's. Second, so these are x equals a function of y. So x equals 2 minus y is to the right. I have an x-intercept of 2 when y is 0, and when y is 2, x is 0. So that's here. That's still that same line. And now I have x equals y squared. So that's 0, 0, 1, 1, 1, negative 1, like this. Then I'm going to have another point of intersection down here. Let's just set these equal to each other and we'll see y squared equals 2 minus y, y squared plus y minus 2 equals 0, y plus 2 times y minus 1 equals 0. So y equals -2 or y equals 1. This is when y equals 1 right here. When y equals 1, x is 1. When y equals -2, x is 4. And I'm interested in this region right here. Okay. And sketch the graphs of the functions being integrated, shade the region. Great. So this is, let's just go ahead and show you how to integrate here. Definite integrals, Desmos can do them. Not indefinite integrals, but definitely definite integrals it can do. Do not use brackets like that. Just use double parentheses like this. Brackets mean something else to Desmos. It means that you want a matrix. That, and so it says that the answer is equal to 4.5 or 9/5, sorry, 9/2 square units. Like that. So that's it for supplemental examples here. You can do a lot of this on your calculator as well. Graph the functions, find the points of intersection. You can even do the shading and get the area of a definite integral just like I did here. You can do that on your calculator. You can just calculate the definite integral on your home screen with a feature from the math menu. You don't have to graph it first and use the second calc menu to do that. So you got a couple different ways to do that. All right, that's it for this video. We'll come back next time and do some supplemental examples from 7.2. See you for the next video.